Hey guys, hopefully everything's going well for you today. What I want to do is talk about, we've been talking about solving quadratics by or we've talked about factoring. And now what we want to do is show you why factoring is important. In order for me to do that, the first thing I want to deal with you guys is something called the zero property. What the zero property says is if I multiply two things together and it equals zero, that means that either A needs to be zero or B equals zero. Okay? Because if I say A is 0 and I do 0 times B, I would get 0. If I say B is 0 and if I do A times 0, I would get 0. Okay? So what I want to do is I want to apply this in a factored form. So what I want to do is I want to look at something like this quantity right here, and I want to figure out somehow what can I put in place of P that makes it 0. Because if I can get this to be 0 times something, it's going to equal 0. So what can I put in place of P that would make that 0? It looks like I could say, hey, P equals -3. And I could kind of guess that by just looking at it. If I make the P opposite, then it would work. But another thing that I can do is literally just set the parentheses equal to 0. Because I'm trying to make this quantity 0. So I get P to be -3. Which means that if I plug -3 into this, and you don't have to do this, I'm just trying to show you guys it works. If I plug -3 into this expression, I should get 0, because I get 0 times 3, which is 0, so that checks out. So what else could I put in place of P to make it 0? So I've looked at P plus 3, and I got it to be -3. If I say, hey, P plus 6 equals 0, if I subtract 6 from both sides, I get P to be -6. So I have two solutions. I got P equals -3, and I got P to equal -6. So if I were to plug -6 into this expression, or here's another thing for me to look at. This expanded, if I multiply it out, I will get P squared plus 9P plus 18 by multiplying it out. If I plug -6 in here, I should get 0. So I get 36 minus 54 plus 18, and that equals 0. So that does check. So all I have to do is if I want to solve this, I want to set x minus 8 equal to 0 and 3x plus 1 equal to 0. So I get x to be 8 and subtract 1, I get 3x equals -1. So x equals -1/3. So I have two solutions. X equals 8 and x equals -1/3. I want you guys to pause it for a second, and then I want you guys to try the next two for me. So if I look at 3 and 4, hopefully you guys paused it and got an answer. If I look at this, I'm going to set 3b plus 8 equals 0, and then b plus 8 equals 0. So I got 3b equals, subtract 8 from both sides, I get -8. I get b to be -8/3. If I subtract 8, I got b to equal -8. And then for the next one, if I set x minus 6 equal to 0, x plus 2 equal to 0, I get x to be 6 and x to be -2. What I'm asked, so now let's apply this in another circumstance. Like looking at 5 and 7. You guys are going to try the other ones in a second. For 5, this is not in this form. If I could get this to be factored, a times something equals 0, I could solve it. So let's factor it out. You guys can do any way that you guys want to factor it out. So I could make a box if I want to, and I could say, hey, that's a squared, that's plus 21. Well, I know 1a times 1a gets me a squared, so that's the only thing. 21 is 3 and 7, 21 and 1. So if I do plus 3 plus 7, what does I get? I get 7a, because 7 times 1a gets me 7a, plus 3a. Those added gets me 10a. So a plus 7, a plus 3, and then I just set them equal to 0. A plus 7 equals 0, a plus 3 equal to 0. I get a to be -7 and a to be -3. Okay, if I look at the next one, I'm going to factor out this one. There's no constant term, so I'm just going to say, hey, what's the greatest common factor of v? So I got v times v plus 5 equals 0. I'm going to set each quantity equal to 0. So v equals 0, v plus 5 equals 0. I get v to be negative 5. In the next video, I'm going to show you guys the answers to 6 and 8. I will talk to you guys soon.